In this lesson, you will learn to multiply and divide rational expressions. Now remember, rational expressions are basically just fractions. So what we're doing in this lesson is we are learning to multiply and divide fractions. Now, yes, you've learned how to do this in the past, but we are now multiplying and dividing in the context of algebra. Where now, instead of just numbers, we have variables and we have different polynomials. So this is going to be a little more involved than what you've learned in the past. Now, many people struggle with fractions, so I'm going to do a quick review with fractions just to remind you of how the laws work. So here we have 3/5 times 2/5. When you're multiplying, you multiply the numerators together, so the 3 times 2, then you multiply the denominators together to get 5 times 5. So what you have is going to be 6 over 25. Here we see 3/5 times 2, and if you have just a number like this, that is the same thing as saying 2 over 1. So then I multiply the numerators to get 3 times 2, the denominators to get 5 times 1, and my solution would be 6 over 5. Now if you have something like this, 3/5 times 15 over 8, I could multiply the numerators to get 45, multiply the denominators to get 40, and then reduce after that. But it's quicker if you can reduce before you multiply. So we see the multiply sign, which means we can kind of extend this, and anything in the top we can cancel with anything in the bottom. So the 5 and the 15 we see are in separate fractions, but I still can reduce, because 15 divided by 5 would give me a 3 over 1. So now I have a 3 times 3 for the numerator, and then the denominator would be a 1 times the 8. So my solution would be 9 over 8. If I'm dividing something, remember division is the same thing as multiplying by the reciprocal. So instead of dividing by 10 over 12, it's the same thing as multiplying by 12 over 10. And then from here, I can simplify. So before I multiply, I can cancel things out, where the 5 divided by 10 would leave me with a 1 over 2. The 12 divided by 3 would give me a 4 over 1. So what I have is a negative 1 times, and actually the 4 and the 2 can cancel again to get 2 over 1. So now I have a negative 1 times a 2 over 1 times 1. So my solution would be negative 2 over 1, or just negative 2. So that is how fractions work when you multiply and divide. And the next example is actually similar to one we've already seen before, but I'm leading you up to the more difficult ones. Here we see 6xy over b to the third times b over 3y to the fourth. Now the same concept that we just used in the review portion of the video is I can extend this line, where now I can cancel anything in the numerator with anything in the denominator. So notice the b over b to the third, this will cancel. I subtract the exponents of 3 and 1 to get b squared, and it's going to be in the denominator because the 3 is bigger, and that's in the denominator. And then the 6 and the 3 can cancel. I'm left with a 2 over 1. And then the y and y to the fourth can cancel. I'm left with y to the third. I'm going to write the b squared up here a little closer. So now what I have is going to be 2. Don't forget the x right there, right, 2x. And then over b squared times y to the third. And that is my solution. Now this works, remember, only if everything is being multiplied and divided together. So we have 6 times x times y divided by b to the third times b divided by 3y to the fourth. Everything is being multiplied and divided. So there's times when it might not be like that. This next example, it is still being multiplied and divided. Even though we see the minus and plus sign in here, they're within the parentheses. So what we have is x times x minus 3 times 2x plus 5 squared, and then divided by x cubed times x minus 3 squared times x divided by this entire quantity of 2x plus 5. So this is everything being multiplied and divided, even though we have the minus and the plus sign. That's because of the parentheses. So from here, I can start canceling things, where I have 2x plus 5 squared right here, 2x plus 5 in the bottom. So I can cancel, and there's 2 in the numerator, 1 in the denominator. So when I divide, I'm going to be left with 1 of these up in the numerator. And then x minus 3's, here we have 1x minus 3, down here there's 2. When I divide, I subtract the exponents. Now I have x minus 3 to the first power, and that's going to go down here in the denominator because this one had more of them to begin with. And then x times x for the numerator, that would give me x squared, right? So if I combine those, I get x squared. But then when I divide that by x cubed in the denominator, that will cancel, and I'm left with 1x down in the denominator. So my final solution, I have a 2x plus 5 left over in the numerator over x minus 3 in the denominator. And that is my solution. And by the way, nothing else cancels. I cannot cancel x with the x up here because this plus sign. This is just one quantity right there. Here's another example where we have y plus 3 cubed over 3y minus 1 times 3y minus 1 over y plus 3. Now when I'm multiplying, I can extend this, and I'm multiplying by this entire quantity, 3y minus 1. This is one quantity down here, 3y minus 1, times the entire quantity of y plus 3. So when I cancel things, the 3y minus 1's will cancel, and then the y plus 3's will cancel, and I'm left with 2 y plus 3's in the numerator, because I had 3 of them on the top, 1 on the bottom. When they cancel, I'm left with 2 on the top. So my solution would be y plus 3 squared. Now here's another one where nothing is factored already, so I need to do the factoring first. So looking at this first fraction, x squared minus 1 over x minus 1, notice x squared minus 1 is a difference of squares. So when I factor that first part, I'm going to have x minus 1 times x plus 1 over x minus 1. Okay, and the second fraction is a little more complicated. Let's look at the denominator first, because that one's going to be quicker. 4x squared minus 1 is also a difference of squares, where I can think of that as 2x squared, then minus 1 squared. So that is a difference of squares, and when I factor, I'm going to have 2x minus 1 times 2x plus 1. And then the numerator, 2x squared minus 5x plus 2, this one is going to be a little trickier because we have the coefficient of 2 being in the front. So I know it's a perfect, or not perfect, it's a quadratic trinomial. So when I factor this, it's going to be something along these lines, where I have 4 blanks to fill in. But the question is, what's going to go there? Well, to figure that out, what I do is I can take this 2, multiply it by this 2 to get 4. And then I ask myself, how do I get 4? Well, 4 can be 1 times 4, or it could be 2 times 2. Or it could be negative 1 times a negative 4, or negative 2 times a negative 2. And the question is, which set of numbers will I use? Well, I need to get negative 5x back out. So I'm going to use negative 1 and negative 4, because when I add those, I get a negative 5. So what I do is, in place of that negative 5x, I'm replacing it with that negative 1 and negative 4. So I have negative 1x and negative 4x. And then from here, I can group and then factor by grouping. So I group these together, group these together, but be careful with the negative sign right here, because when I have the negative sign, I need to change this from a positive into a negative. So it's going to be 2x squared minus 1x, and then minus 4x, then minus 2. So now I need to pull out the greatest common factor for each set of terms. So for the first set of terms, they both have an x in common. So I pull an x out, and I'm left with a 2x minus 1. The second one, they both have a 2 in common. So I pull a 2 out, I'm left with a 2x minus 1 over here. So then to factor by grouping, I see they have a 2x minus 1 in common. I can pull out a 2x minus 1. I'm left with, in parentheses, the x and the minus 2. So over here I have 2x minus 1 times x minus 2. And now everything is factored. I can then proceed to cancel. So I can extend this because you're multiplying, and anything in the numerator I can simplify with anything in the denominator. So here the 2x minus 1 cancels with 2x minus 1 right there. X minus 1 cancels with x minus 1 over there. So what I'm left with would be an x plus 1 times x minus 2 over 2x plus 1. And that would be my solution. Let me walk you through one more example for this lesson. Here we have this last example, where we now have three things multiplied together. And actually here we have division, but remember, division means multiplying. What we're multiplying is we can multiply by the reciprocal. So instead of dividing by x over x squared plus x minus 2, I'm multiplying by x squared plus x minus 2 over x. Okay, and everything is pretty much done. The only thing I need to do is right here, x squared plus x minus 2, I need to factor that. So x squared plus x minus 2, I can factor, and I know it's going to be an x and an x to get x squared. So that first term is good. Negative 2, I need a 1 and a 2 to get negative 2. 1 needs to be positive, 1 needs to be negative. If I have a positive 2 and a negative 1, they would multiply to get negative 2. They would add to get a positive 1x. So I can factor to get x minus 1 times x plus 2. And then from here, I can start canceling things. X minus 1 cancels with x minus 1 up here. X plus 2 cancels with x plus 2. X and x squared can simplify, and I have 1x remaining in the numerator. And that's it. So my solution would be x times x plus 1. And that concludes our lesson for today. We will see you next time.